Good morning, friends, and welcome to another episode. We'll be looking at bonding, but in today's episode, we'll look mainly at covalent bonds. In our previous episode, we looked at ionic bonds and how ionic bonds are formed. And I remember whilst looking at ionic bonds, we made mention of the fact that in ionic bond formation, we have one atom that will transfer electron to another atom. So, for example, in ionic bond formation between sodium and chlorine, sodium has electronic configuration of 281, whilst chlorine has electronic configuration of 2, 8, and 7. So their valence electrons, sodium has 1, chlorine has 7. So what happens is that because sodium would have to lose its electron and chlorine would have to gain 1 electron, sodium would have to give its electron to chlorine. And in the process, they come together to form a bonding relationship, sodium or the compound sodium chloride. So that was what we looked at under ionic bond formation. Now, in today's episode, covalent bond formation, the story is a little different. So let's jump into it. Now, in this situation, for example, let's say we have an atom A and another atom B. In covalent bond formation, you have the situation where both atoms that are involved in the bond formation are in need of electrons. Remember, in ionic bond formation, one atom is in need of the electrons while the other atom gives out its electrons. So one gives out and the other receives. Now, in the case of covalent bonding, one atom needs electrons to stable, and the second atom also needs electrons to be stable. So A needs electrons to be stable and B also needs electrons to be stable. So what it means that if for these two to come together, there will not be that need for one to transfer electron to the other. In situations like this is what happens. Because both atoms need electrons for them to be stable, what they do is this. The first atom, in this case A, will donate electrons into maybe something I would describe as a bucket. So to donate electrons into that bucket. Of course, it's not the bucket, this is just an illustration. Then the second atom, B, will also donate its electron, maybe one, so one from each atom into that bucket. Now, once they do that, they form what we call electron pairs. Now, after forming electron pairs, what they do is that they now come and share the electron pairs. So they share the electron pair. And we'll be using an illustration for this. And I believe the illustration will make you understand this better. So let's look at an example. Let's take an atom such as chlorine and another chlorine. Chlorine's electronic configuration is 2, 8, and 7. This second chlorine has the same electronic configuration, 2, 8, and 7. Now, so you realize that the first chlorine needs just one electron to be stable. The second chlorine also needs just one electron to be stable. So each of them need electrons. So what they can do is this. The first chlorine So remember, the focus first is on the valence electron. So what you can do is this: the first chlorine, out of the 7 valence electron, it can give one out, one electron into, let's say, the bucket. So you are left with 6 electrons. The second chlorine would also give out one of its electrons, meaning you are left with 6 electrons. So you have this here, and these 2 electrons will form what you call electron pair. Electron pair simply means 2 electrons. That's what it means. So they form electron pair. After doing that, the 2 chlorines can decide, okay, then we can share this electron pair. So look at what is going to happen. Now, chlorine, the first chlorine, this chlorine has 2, 8, and 6. So if it's going to share with this one, what it means that it would have 2 from here. So now look at what is happening. You have 2, 8, then the 6 plus the 2 will give you 8. So you realize that now this satisfies the octet rule. Let's look at another example for the second chlorine. In the case of the second chlorine, you are left with 6 electrons. So first, the configuration is 2, 8, and 6. So this will now come and share with this one. So the 2 will be added to the 6. So this 2 and the 6 will give you 8. So it's now satisfying the octet rule. So the takeaway point is this: in covalent bond formation, the atoms involved, what they do is they share electron pairs, which they themselves have donated. So they donate electrons and they share those electron pairs. And so let's look at another example. I believe that example would also help you understand the concept better. So this time I'm going to take hydrogen and I'm going to take chlorine. So hydrogen has 1 electron, that's the electronic configuration. It's 1. Chlorine's electronic configuration is 2, 8, and 7. Now, for hydrogen to be stable, it needs to observe what you call the duplet rule. So the valence shell should have 2 electrons. Here in this case, it has only 1. So what it means that hydrogen needs 1 more electron to satisfy or to be stable. Chlorine, on the other hand, would need to satisfy the octet rule. What it means that it needs 1 more electron to be stable. Remember, we are focusing on the valence shells. For chlorine, it has 7 electrons in the valence shell, so you need to satisfy the octet rule. For hydrogen, it has just 1 electron in the valence shell, and it needs to satisfy the duplet rule. So this is what happens. Hydrogen can donate the 1 electron. Chlorine, out of the 7 electrons, can donate 1 electron to form what you call electron pairs. So there is no more electron here. This electron has been donated. Here, 1 has been donated, so we are left with 6. So after donating the electrons, they can now share the electron pairs. There is nothing here because it has been donated. So now hydrogen comes here and it wants to share this electron pair. And it does that, and you realize that its electronic configuration will now be 2, which is stable because this configuration now satisfies the duplet rule, 2 electrons in the valence shell. So now let's look at that of chlorine. Chlorine was left with 6 electrons after donating 1 of the electrons in the electron pair. So what happens? It now comes here. The chlorine now comes and it shares those two electron pairs. So it takes the two electron pair and it adds it to 6. 6 plus 2 will now be 8. So that satisfies the octet rule. So chlorine is also stable. Again, and I'm going to repeat this, in covalent bond formation, electrons are donated by the two atoms involved, or maybe two or more atoms involved, and these donated electrons form what we call electron pairs. And the process, the two atoms or the atoms involved share the electron pairs in order to be stable. Let's use a final example to explain covalent bonding. And in this example, we are going to use, let's use oxygen. So we would use oxygen to explain this. So let's take oxygen, let's take another oxygen. This oxygen has atomic number of 8, atomic number of 8. Electronic configuration will be 2, 6. The electronic configuration of this will be 2 and 6. Now, oxygen needs 2 electrons to be stable. Remember, the valence shell has 6 electrons, the valence shell has 6 electrons. So for it to be stable, it needs to observe the octet tree by gaining 2 more electrons. So because each of them needs 2 electrons, you don't have the situation where one can provide the electron. So what can we do? We don't have to donate electrons. And in this case, oxygen will donate two of the electrons. So oxygen will give two. This oxygen, it will give two of the electrons. And this second oxygen will also give two electrons. So you have two pairs. So in this case, you are having two pairs of electrons. And in situations of oxygen, that's what happens. Two pairs of electrons are going to be shared in a total of giving a total of 4 electrons. So these two pairs of electrons are going to be shared. So this is what happens. After giving the 2 electrons, you are left with 4 electrons here. You are also left with 4 electrons here. Now, let's see what happens to electronic configuration at this point that oxygen wants to share. So you now have 2, 4 plus the shared electron. Remember, the shared electron is this one. That is 4. So this satisfies the octet rule of 2 and 8. This is stable. Let's come to the second oxygen. You are left with 2, 4. And this again, the next we plus the shared electron, which is the 4 here. So that will give us 2 and 8. So this is also stable. So the point is this. So oxygen, the two atoms involved, they donated electrons. And after donating those electrons, they shared to form electron pairs. They shared those electrons. That is basically what covalent bonding is all about. So they form something like oxygen 2 because of the two oxygen atoms involved. So I guess that will bring us to the end of how covalent bonds are formed. Then maybe the final thing you need to remember is this. You realize that covalent bonds are usually formed between known metals. So for example, oxygen combining with another oxygen. Oxygen is a known metal, the other oxygen is a known metal. So they are able to join together. Let's look at even the other examples. Hydrogen is a known metal, chlorine is a known metal. They join together. Then final example, you realize that chlorine is a known metal, this chlorine is a known metal. So covalent bonds, one of the important things you need to take away is that they are also formed between known metals. I guess that will bring us to the end of today's class. Please share the video if you've not done that. And subscribe. Give me thumbs up so I can be encouraged to do more of these videos. Thank you very much. We'll meet again in the next episode. You take very good care of yourselves. Bye.